Good evening to all. Am I audible? Can anyone inform? Okay, today I will discuss the numerical problems on block diagram. So how to reduce the block diagram and how to determine the transfer function for the given system. Okay, so we'll solve some numerical problems in today's session. So this is my numerical problem. Reduce the block diagram shown in the figure and find C by R. So what is C here? So question is what? Reduce the block diagram shown in the figure and find C by R. What is C here? C is the output and R is the input. So we have to determine C by R. Okay. So they have, even though they have mentioned, simply they have mentioned find C by R. Okay. Even though it is mentioned simply find C by R, we have to find the transfer function in Laplace. Okay. We have to find the ratio of output by input in Laplace form. That is the transfer function. Simply, even if they mention C by R means they hadn't mentioned C of S by R of S, isn't it here? So it is understood. Okay, even if it is mentioned C by R, it is understood that C is C of S, R is R of S. Of course, at last we won't write C of S and R of S, but it is understood that C is C of S and R is R of S. Now, in this block diagram, you just carefully observe. There are two summing points. This is one summing point. This is another summing point. Okay, and this is our path from input to output. Okay, from R to C. So you can see two gains G1 and G2 in this path. Okay, and we can see another a loop type. You can see a loop type here. In that loop, there is a gain H. Another loop is there. In that loop, gain is G3. So, first of all, we must check the cascade blocks. So, there are no cascade blocks here. But of course, if suppose this branch point is shifted behind to G1, okay, then G1 and G2 will become cascade, isn't it? That can happen. Okay, G1, G2 will become cascade, or see, everyone will not get the same thought, or if this branch point is moved ahead of G2, then also G1 and G2 will become cascade. Okay, we can follow either case. Okay, we can follow either case and we can simplify the given block diagram. So, so you can note down this question. You can write down the question and you can note down this diagram. And if you, as soon as you complete, you can mention in the chat box. I hope you might have already drawn this. It's very simple circuit, isn't it? So we have two cases here. You see, everyone can't think in the same way. So either you can move this branch point behind G1 or in front of G2. We can do any of those two. So let us see what I have already done. So what I have done is, okay, so I told you something, but I have done something else. It's okay. So we can even move. I didn't see what I told, that was also correct. But already what I have done here is, I have moved this branch point ahead of G1. Okay, ahead of G1. So some people may think that ahead of G1 means this branch point should move And this cursor, it is irritating. Okay. So if ahead of G1 means this branch point will move here, isn't it? Why it has moved ahead of another branch point? Okay. Some people may get that sort of thought. See, branch points can move if they are moving ahead of a block, even if there is another branch point, you can simply interchange those branch points. See, I can, instead of putting the arrow mark after that branch point, um, see, I will just carefully draw. See, I can move this branch point ahead of this block. Okay. So if I move the branch point ahead of this block, so what will happen? So this, what is the signal that is moved here? What is the signal? This signal is moving ahead of G1. Okay. The above loop is moving ahead of G1. So whenever a branch point moves ahead of G1 or any block, what should happen? In that particular signal, okay, reciprocal of that gain. So means 1 by G1 value should be, okay, G1 value should be written in a block. Okay, that you have to do. So this branch point, for your own satisfaction, instead of drawing it here, I will draw it here. So let us assume this is not there, this is not there. So this is not there. Let us assume this is not there. Now I will take the pen and I will just cut this. Let us assume this is not there. I am just cutting it. It is not there. Now what are there? These two. There are two branch points which are besides to each other. So if two branch points are cascade, you can interchange the positions of the branch points without disturbing any block. Okay, you can simply interchange the branch points without disturbing any block. So here, even if you draw the branch point here, even if you shift this branch point from here to here, I will take the laser. Yeah, see, from to this point. Okay, so you will get somewhat like this. You will get this diagram. The block diagram will look somewhat like this. Now, if you see here, 1 by G1 and G3, they are cascade. And if you carefully observe, from this branch point, signal is going to this block. From this branch point, signal is going to this block. So, their input signals and their output signals, G2 output signal, G3 output signal, are ending at the summing point. So, we can say this G2, 1 by G1 and G3, they are in parallel to each other. Okay. So, but this branch point is in between this branch point and G2. Okay, so simply you can write step 2 as interchanging the branch points. Okay, you can write step 2 as interchanging the branch points. So if you people are copying it down, no need to draw this first diagram. You can directly draw the second diagram, moving the branch point after the block or ahead of the block. Okay, so after the block means ahead of the block, moving the branch point ahead of the block, or moving the branch point after the block. So I will once again go back to the question. This is our question, isn't it? So earlier I told you that we can move this branch point behind G1 or after G2. Okay, you can move them behind G1 or after G2 if suppose the first case which I have considered before, so showing you the solution what I have already done. Okay, so if suppose I move this branch point ahead of G2, what will happen? Another block will come into existence here whose gain value is 1 by G2, whose gain value will be 1 by G2. So what will happen to this diagram? Summing point, isn't it? For the case which I have discussed earlier, that case I am drawing the diagram here. So this is our summing point. So okay, I'm roughly drawing it. So this is G1 block. So this G3 is there. This is G3. Okay. And now from this arrow mark should be drawn here. I didn't draw arrow mark. This is arrow mark, arrow mark. Arrow marks, you should not forget the arrow mark signals. So this is my H. Okay. And this is my branch point now. Now G1, G2 are in cascade. So what you can do, you can replace the G1, G2 with a single block. So, what I am going to do is, I will draw that block. So see, first of all, I started with some concept, but my solution in my PPT, it is that I have done. Okay, I have erased everything. Very good. Okay, so this is my summing point, and G1, G2 are in cascade. So this is G1 and G2 are in cascade. You can do that also. There is another summing point. Okay, and here, this is it. This is my H block. This is my summing point. And what is this? G3 is there. Okay. Okay, leave it. Here C is there. Here input side, arrow mark, R is there. Now if you observe carefully, G1, G2 are in cascade, and this is plus and this is minus. G1, G2 are in cascade. Now how is the signal flowing from this summing point? Signal flows like this. It is flows like this. From this summing, this branch point, see, this is a branch point. From this branch point, the signal is returning back. Here you can see the arrow mark. So this is a feedback path, negative feedback path. So what is the negative feedback path gain here? G1, G2. Okay. G1 into G2. I will simply, it's better if I speak orally instead of using this cursor. Okay. G1 into G2 divided by 1 plus G1 into G2 into H. G1 into G2 into H. This is the gain value. Feedback loop. Eliminating this feedback loop. Okay. Eliminating this one. This feedback loop. What do I get? G1, G2 divided by 1 plus G1 into G2H. I hope you are able to follow. So I will just remove all this. Okay. Now I have eliminated the feedback loop. So if you think whatever I am writing is bit confusing to you people, now this summing point will be eliminated because you have eliminated the feedback element. Okay, I will show you what I have already done. That I will show you later. Now a new thought. See, always I won't think in the same way. New thoughts comes to my mind again and again. So I won't always solve the problems in the same pattern. That's the problem with me. Okay, so I can't by heart everything, any concept, and okay. So this is it. This is the block. Now what is here? Plus is there. Here plus is there. Now how is G3 and this G1 G2 by 1 plus G1 G2H? How are those two? They are, how are they? They are parallel or or they are forming a cascade connection. What is this connection? Can anyone mention in the chat box? G1 G2 by 1 plus G1 G2H and this G3. They are connected in parallel or they are connected in cascade? Okay. So these two are in parallel, isn't it? So this is our input signal. It is starting from this branch point, and it is flows like this, and set this summing point. Okay. So what is it? G1 G2 by 1 plus G1 G2H plus G3. Okay. So this is it. So you can put it in a block. You can put it in a block. And what is our input? R. Input is R. Output is C. Okay. So now what is C by R? G1 into G2 divided by 1 plus G1 into G2H plus G3. Okay, that is it. That is our uh, transfer function. Okay, for this method which I have followed, which I have not drawn here in this. Okay, so I have followed some other method here. So already I have determined the transfer function. In this one slide itself, I have drawn the determined the transfer function. You can further simplify. You can take common denominator and you can rewrite this equation again. Now let us see what I have already done earlier. What I have done. Okay, earlier what I have done, that we will see. Okay, something. Okay, so what I have earlier, what I have done, let us see that. So here simply what I have done, no need to draw the first diagram, all of you. No need to draw the first diagram. You can directly do this, draw the second diagram. What is my step one? Okay, so without any steps I have drawn in the first slide. Forget about it. If you, it might not be more clearer when compared to with these images. These images are more clearer to understand, isn't it? So I took some other path at the beginning. So I thought let me complete that path and return back to this another method. So you people, you all of you won't get the same thought. So even myself, once I solve a problem in one method and later I solve it in some other method. Okay, always same thoughts won't come to my mind. Similarly, here what I have done is step one, move the branch point after the block, means ahead of the block. So this is my branch point. I have moved it ahead of the block. Okay, you can put the branch point. Okay, even here also I'll take the list. You can put this branch point here. Arrow mark is jumping this branch point, isn't it? It is jumping and it is going ahead of the branch, this branch point. Okay. This branch point is moved ahead of G1 as well as this branch point. So don't worry if you are jumping the branch point or moving the branch point ahead of another branch point, because branch points can be interchanged without any issue. Okay. No need to modify anything. So I have moved it. So another block came into existence. What is this block in this signal? In this particular signal, to this branch point, which signal is connected? This signal, G3 signal, isn't it? So this signal, in this one more block will be introduced, whose magnitude should be the reciprocal of this gain value, ahead of which the branch point is moved. So this branch point is moved ahead of G1. So in this signal, another block should be introduced whose gain should be reciprocal of this G1. So 1 by G1 and G3. Now if you observe carefully here, G1 and G3 are connected in cascade, and if you carefully observe from this branch point, one signal is moving upward, another signal is moving forward, and this upper signal moves like this and ends at this summing point. This signal which is standing from this branch point moves ahead and ends at this summing point. So I can say G2 and this G1, 1 by G1 and G3, they are in parallel to each other. Okay, they are parallel to each other. So I hope you have drawn this. So I hope you have drawn this. Let us move further. What is my step number 2? Okay, my step number 2 is okay, I will take the laser. Step now, eliminate the feedback path and combining the blocks in cascade. So I didn't see this feedback. This is a feedback. So cascade blocks I have combined, and this is my parallel path. See, that's what happens. Okay, I do something, I tell something. It's okay. So these two blocks are cascade dotted lines, and if you observe here, this path you just observe. What did I do from summing point? Signal flows from summing point to branch point. From branch point, signal returns back. Okay, there is a return path. If there is a return path, that means that those two blocks are the return path is there, means it is feedback loop. Okay, if there is a return path, that means that it is a feedback loop. Okay, return path means feedback loop. So I will erase all links and I will mention. So this is it. What? This is feedback loop, because there is a return path. Okay, feedback loop. And these two elements, of course, they are cascade, and this cascade combination and G2 are in parallel to each other. Parallel. Okay. I am talented enough. My cursor won't listen to me. Okay, parallel. I can't write parallel here. Okay, you people, no need to write parallel. So no need to draw the first diagram. In the first diagram, simply I have mentioned the dotted lines. You can directly draw the second diagram. What is negative feedback path gain value? What is it? I will erase all the inks. So these two are G1 and H are forming feedback loop, and this parallel combination and G2 are forming this cascade combination and G2 are forming a parallel path. Okay, so we can at a time eliminate all these. No need to do all steps at a time. So this feedback loop gain value is how much? G1 divided by 1 plus G1 into H. That's what I have written here. G1 divided by 1 plus G1 into H. Now you just multiply G3 and 1 by G1. You will get G3 into G1, because G1 by G1 and G3 are connected in cascade. So now these two are parallel. So what you have to do, see here, you eliminate this parallel path. G3 divided by G1 plus G2, or G2 plus G3 divided by G1, your wish. Whichever term you want to write first, your wish, you can write, it doesn't matter. Okay, so no need to write, it is not compulsory that you must write G3 by G1 first and later you must write G2. Okay, it is not necessary, your wish. If you want to write G2 plus G3 by G1, you write it, or if you want to write G3 by G1 plus G2, you can write it. So next step is what? Step number 3. Step number 3 is to eliminate the parallel paths, and after that you can get combined cascade blocks. Okay. I hope you have already written. Let us go to the next. So combining what? Parallel blocks. So these are the parallel. No need to draw the first diagram if you are copying it down in your notes. No need to draw the first diagram. Draw the second diagram. So R G1 by 1 plus G1 H plus what did I write? G2 plus G3 by G1 I have written. If you want, you can write G3 by G1 plus G2. It doesn't matter. So this is it. So if you complete, just inform. So you can follow any method. If you follow the rules, that are more than sufficient. Method is not important. Following the rules for reducing the block diagram is important. Now what is step number 4? Step number 4 is what? Step number 4 is combining the cascade blocks. So I hope you have completed. I am just changing the slide. So combining the cascade blocks. If you combine the cascade blocks, what you have to do? You have to multiply the gain values. So what is it? G1 by 1 plus G1 into H into G2 plus G3 by G1. So that's what I have written here. What is it? C by R is equal to G1 by 1 plus G1 into H into G2 plus G3 by G1. Okay. So I have taken common denominator for this within the brackets term. What do I get? G1. Okay. In the denominator G1, in the numerator G1, G2 plus G3. Now multiply these two terms. What you will get? G1 into G2 plus G3 by 1 plus G1. Now draw a single block and you just write down this gain value inside that block, mention R as input and C as output. So what is the overall transfer function? See, in the question they didn't mention overall transfer function, simply they have mentioned C by R. So we have to understand that C by R is nothing but overall transfer function in Laplace. Okay, C of S by R of S, if you want you can write, but it is not mentioned in the question, so we will not write. So C by R is equal to G1 into G2 plus G3 divided by 1 plus G1H. Okay, you can just copy it down. If you complete, just inform. Okay, I hope you have completed. Now let us see another numerical problem. In this problem, obtain the transfer function for the given block diagram. Simply they have mentioned obtain the transfer function for the given block diagram. So this is our block diagram. You can see input they have clearly mentioned R of S. Output what did they mention? Y of S. So notations, their wish. Whatever notations they give, we will assume the left side term as input, isn't it? Where is my cursor? This term as input and this right side term as output. Extreme left side in is input and extreme right side as output. That's it, not more than that. Okay, input is R of S, output is what? Y of S. So if you see here carefully, okay, so if you see here carefully, there is a summing point. So plus inside the summing point, they didn't draw the plus the sign values, summation values. If you want, you can write if you have sufficient space plus plus. Okay, here outside I have drawn. If you want, you can draw in the summing point. This is plus, this is minus. Here, this is plus, this is minus. Here, this is plus. If you want, you can, it's better to draw the values within the summing point. Means values means the signs, plus and minus sign within this summing point. So this is plus, this is also plus. Okay. So you just take a minute and you draw the diagram. As soon as you complete, mention it in the chat box. Please mention in the chat box as soon as you complete. Okay, one thing you just remember, stepwise you can perform each task one after another, or you can perform multiple tasks in each step. For example, if you see here, if you carefully observe in this diagram, G1 and G2, how are they? They are connected in cascade. You can mention in the chat box. Okay, G1, G2, how are they connected? They are connected in cascade. Okay, and if you observe G3 and G4, how are they? G3, G4, can anyone mention? Is it a feedback loop or parallel path? G3 and G4? Someone has asked to wait. I didn't change the slide, isn't it? Okay, you people, if anyone is writing it down, you can write it down. No need to worry. I didn't change this slide. So see, G3 and G4, how they are connected? Are they connected in parallel or is it a feedback path? So just carefully observe. You can mention in the chat box. G1, G2, it is clearly understood that G1 and G2 are in cascade. What about G3 and G4? Signal starts from here, ends at this summing point. Signal starts from this branch point, ends at this summing point. Signal starts from this branch point, travels like this and ends at this summing point. So starting point and ending point are same. Signal is not returning back here. So G3 and G4 are connected in series or parallel or feedback. They are connected in parallel. Okay. Both G3 and G4 are connected in parallel. G1, G2 are connected in cascade. So step 1, I can say combining the cascade blocks. Step 1, I can say combining the cascade blocks. Or I can say combining the cascade blocks and eliminating the parallel path in step 1. Okay. Our wish, whatever we want, we can do. Okay. We can perform multiple tasks at a time. So as a beginner, it's better if you follow these steps one after another. But here I have already in the solution, you can see in step 1, what did I do? Combining the cascade blocks G1, G2 as well as eliminating the parallel path of blocks G3 and G4 I have written. So if you want, you can write like this. Step 1, you can do that. So combining cascade block G1, G2 are cascade. So just multiply the gain values. G3, G4 are in parallel. So add the gain values G3 plus G4. Also, for each and every step, we have to redraw the diagram again and again. So just redraw the diagram and see what else can be done. Next step. What can you do in the next step? What can you do in the next step? You can mention in the chat box what can you do in the next step. What can you eliminate? You just mention. So someone has mentioned that they need an explanation for the elimination of parallel blocks. Okay. So okay then. So let us get back to the question. Let us get back to the question. So see here, this is our question, isn't it? So you just observe carefully G3 and G4. Behind G3 and G4, there is a branch point. Ahead of G3 and G4, in front, ahead means in front of G3 and G4, there is a summing point, isn't it? There is a summing point. So you just carefully observe the signals. Signal arrow marks. Signals means arrow marks here. You just carefully observe the arrow marks. So here, this arrow mark you see from this branch point, it is moving towards G3. From G3, it is moving towards summing point. This from this branch point, signal has started. It is moving towards G4. From G4, it is moving towards summing point. So, from this branch point, signals have started in two directions. Okay, and they have ended at common point. So, starting point and ending point are common. Okay, so starting point and ending point are common here, isn't it? So, suppose water from a pipe, water has started to flow. In this is a pipe, water is flowing. From here, two paths have emerged. So water will flow in this direction as well as it has divided and it is flowing in both the directions. Now, these two pipes, once again they meet at some common point. Okay? They meet at a common point. So water, what will happen? Even though it has divided in two paths, it will combine here and it will flow in. If the channel, two channels become single channel, it will flow like this. Okay. So their starting point is from same point current has divided or water direction has divided. At same point water direction has added up. Okay. So at same point, let us assume current. Current here, there is no current, but let us assume current has divided at branch point. Okay, in two paths, and current has been added at this summing point. Okay, so the signal is the two signals. If they start from the same point and if they end at the same point, okay, if two signals start at the same point and end at the same point, then those two gain values in those two signals, those gain values are said to be connected in parallel to each other. Am I clearer to you? Whoever has mentioned they need an explanation. Okay, so G3 and G4 you just observe here. H is not there. Okay, in the question whatever they mentioned, that we have to consider. If H is not there, what can we do? Okay, someone has mentioned H. I didn't understand properly. What is meant by H there? Here, whatever notations they have mentioned, you consider that. H is not there. Simply, you just carefully observe G4 and G3. Signals behind them have started from common point, and after them they are ending at the common point. So they have signal has started. Two signals have started from this branch point. They are moving. One signal is moving towards G4. One signal is moving towards G3. And ahead of G4, that same signal continues and ends at summing point. Ahead of G3, same signal continues and ends at summing point. So G3 and G4 are said to be connected in parallel to each other. Okay, they are said to be connected in parallel to each other. Okay, so if two blocks are there, behind them, if two signals are starting from common point and ahead of those two blocks, signal ends at common point, those two blocks are said to be connected in parallel. So am I clearer to you? Whoever has mentioned in the chat box, you can mention it. You can comment whether you are able to understand or not. So G3, since G3 and G4, they are connected in parallel. So we can say, we can add those gain values G3, G4 and G1, G2. They are connected in cascade. Therefore, we have multiplied G1 and G2 values. Okay, this diagram, I hope you, if you have completed step 1 diagram, did you complete or not? If you have completed, at least type C. If you have completed step 1 diagram, so that I will proceed. Now, what is coming to your mind? What is coming to your mind? What is coming to your mind? You just carefully observe here. What comes to our mind? Now, this is our diagram, block diagram. Now, modified block diagram. Now, what comes to our mind? You just carefully observe here. G1 and G2. From this summing point, signal flows through G1 and G2. From this branch point, what is happening? Signal is returning back towards the summing point. There is a return path, isn't it? Signal return path is there. Okay. So if blocks are connected in parallel, you have to add the gain value summa. That is the rule. You must know the rules before going for block diagram reduction. Okay, there are some rules that are to be followed, okay, for block diagram reduction. So those rules, if you have already learned the control system subject, you might be knowing, or before solving the block diagram, okay, you must know the rules. There are some rules that are to be followed. If blocks are connected in cascade, you must multiply the gain values. Okay, if blocks are connected in parallel, you have to add the gain values. Those are the rules that are to be followed. That's it. It's a rule. That's what we are following in control system. For block diagram reduction, some rules have been framed by the engineers who earlier developed this concept. Okay, so whatever rules that they have framed, those rules we are following to reduce the block diagram to get the required transfer function. Okay, that is it. It's a rule. That's why we are following. So there are some approximately 11 rules which are to be followed. Okay, so that's why we are adding G3 and G4. Why we are adding means they are connected in parallel according the rule, one of the rule of block diagram reduction. If blocks are connected in parallel, their gain value should be added. That is the rule. Okay, that's the only explanation that I can give you. Now you just observe here G1, G2 and H1. They are in there is a feedback path, isn't it? There is a return path here within this loop. That means this whole system, this is a feedback loop. Okay, this is a feedback loop. So this is a feedback loop. So you can eliminate the feedback path. Next step number 2, what I can do, I can eliminate the feedback path. One more thing came to my mind, that this G5, G3 plus G4, those two blocks, G5 block, G3 plus G4 block, they are, you see, if this branch point was not there, they might have been in cascade, isn't it? If this branch point might have not been there, then I could have multiplied G5 with G3 and G4. So I could have said that G3 plus G4 are in G3 plus G4 are in series or cascade with G5. Okay, so in next step what I am willing to do is, I just want to, what I want to do is, I just want to move this branch point ahead of G5. Okay, ahead of G5. Okay, so if you want to move this branch point ahead of G5, what is the signal that is connected to this branch point? This is the signal in which what is the block? H2 is there. Already H2 is there. Okay, so in this, when you move this branch point ahead of G5, what will happen? A block will come into existence here in series to H2. Okay, so what is that block? It is jumping G5, isn't it? It is moving ahead of G5. So the block value is reciprocal of G5, 1 by G5. The gain value in this block will be reciprocal of G5. That is 1 by G5. So let us see how to do. I hope you have already drawn while I was giving the explanation. Let us go to step 2. Okay, step 2. Step 2 is what? Cursor is not working. Step 2 is what? Eliminating the feedback path of blocks G1, G2 and H1. That is this. And also shifting takeoff point after the block G5. Okay, that I have done already. So now eliminating the feedback path. What was in step 1? I just want to go back. Okay, I just want to go back. See, what was the feedback? It was negative feedback. Here minus is there. Okay, so negative feedback. So what is the gain value of this feedback? When you eliminate the feedback, what do you get? G1, G2 divided by 1 plus G1, G2 into H1. That's what you will get. Okay, G1, G2 divided by 1 plus G1 into H1. Eliminate the feedback path. No need to draw that summing point. Some students, you know, they eliminate the feedback path, but they will once again draw the summing point here. No need to draw the summing point. Okay, once you eliminate the feedback path, the summing point which was connecting the forward path gain block and feedback path gain block, that summing point has to be eliminated. Okay, no need to draw it again and again. So this is it. Now this is the eliminating the feedback path, and I have moved the branch point ahead of G5. Okay, I have moved the branch point ahead of G5. And see, I have multiplied it, isn't it? So take simply, I didn't mention here. I simply take off point after the block G5. That's what I have mentioned. So actually, I have done two operations here. I have moved the branch point ahead of the block. I have multiplied the cascade blocks. Actually, this is what H2 and 1 by G5 should be there. H2 and 1 by G5 are cascade to each other. So in the same step, you can mention that combining the cascade blocks. Okay, and combining the cascade blocks, you can mention that. What are the cascade blocks that you are going to get? H2 and okay, H2 and G5, 1 by G5. So H2 and into 1 by G5 means H2 by G5. That's what you will get. So combining cascade blocks, you can add one more statement there in the above step. Okay, so you can add one more statement. So if you have completed this, please mention. So now immediately by looking at this diagram, what I can say next step, what I should write, combining the cascade blocks. Next step. Okay, in the next step, what I should write is combining the cascade blocks. Okay, next step will be. So if you want to know the rules, whoever has mentioned, I can make the video on rules of block diagram reduction. You can go through those rules. So I hope you have written. I will go to the next step number 3. So in step number 2, what did I do? Combining the cascade blocks G3 plus. So see, it has overlapped here. It has overlapped. I will just move this. Okay. So this is it. See, combining cascade blocks. Which blocks? G3 plus G4 and G5. Combining means cascade blocks means you have to multiply the gain values. Okay. Simply you have to multiply the gain values. So I have multiplied the gain values G3, G4 and G5. Okay. I have multiplied the gain values. This is what I have got. Now if you carefully observe here, what can we do? What can we do? Let us see. It is important. This is important. I don't know how many of you are carefully listening the class. Huh? This is important. Why? Because you just observe here. This is my summing point, isn't it? This is a summing point. This is a summing point. From here, signal just flows like this towards the branch point. This is my branch point or takeoff point, I can say. Okay. From this branch point, what is happening? Signal is returning back towards the summing point. So, it is returning back towards the summing point means what is this? Is this a parallel path or feedback path? Okay. H3 is the feedback path. H3 is the feedback path gain or no? Or parallel path gain? H3 is feedback path gain or parallel path gain. You can mention in the chat box. What is your opinion? What do you feel? Okay. So, just carefully observe. Where is my cursor? This is my summing point. From this summing point, signal starts. It moves like this. It moves upward. I will take the laser. I will take the laser. See, from this summing point, signal start. It moves like this. From this branch point, it just return back to the summing point. If signal is return back to the summing point, that means that it is a feedback loop, feedback path, okay, or a feedback loop. So there is a feedback loop here. This is a feedback loop. And what type of feedback is it? What type of feedback is it? You just see here, what is here? Minus. So negative feedback loop. Okay, yeah, it is feedback path. And what type of feedback? Positive or negative? Negative. So signs are very, very important at the summing point. If you forget to write plus, minus and all, if they in the question, if they don't mention, you consider negative feedback. That's it. Okay, no need to consider positive feedback. If in the question itself, the examiner forgets to mention the negative symbol, negative or positive, whatever, If they forget to mention these signs, plus or minus signs at the summing points, you people have assume your own signs, and I would recommend that you always assume for feedback, you always assume negative sign. Okay? Because if they have not mentioned or wish, we can assume any sign. So it's a negative feedback. So eliminating this negative feedback loop, what do you get? What do you get? What is forward path gain? What is forward path gain? Lower one, H3 or G3 plus G4 and into G5, which is forward path. Okay. So negative feedback. Okay. Someone has mentioned. So which is forward path gain? Which is it? H3, H3 is forward path gain or feedback path gain? See, signal has started from summing point. It has moved through G3, G4 up to G5. From G5, what is happening? Signal is returning back. Signal is returning back through which gain? H3 gain. So H3 is our feedback gain. So H3 is feedback gain. Forward path gain is G3 plus G4 into G5. So what is the after eliminating? What do you get? After eliminating the feedback part, what do you get? G3 plus G4 into G3 plus G4 into I will not erase and write again and I don't have that much patience. See, my cursor won't listen to me. Into G5 whole divided by what? Oh no. Whole divided by, at least I will write the line straight line. I will draw the straight line. Yeah, it's okay. I can manage with that. 1 plus what? G3 plus G4. I didn't take eraser. Okay. G3 plus G4 into G5 into G4 into G5 into what is it? H3. That's it. That's the formula. Actually, no need for me to write. Why? Because I have already typed it. Okay. This is H3 into H3. That's it. This is the formula. I will just erase unnecessary brackets. Okay. This is it. This is the gain value. Eliminating the feedback path. This is what you will get. Okay. Eliminating the feedback path. This is what you will get. I will just once again draw that. This is G3. Okay. This is what you will get. So now I hope you have drawn this diagram. Let us go to step number 4. What is step number 4? Step number 4 is eliminating the feedback path. Step number 4. Eliminating the feedback path. So step number 4, I hope you have completed step number 3. Meanwhile, I was explaining. Step number 4 is what? Eliminating the feedback path of blocks. See, no need to write this G3 plus G4 into G5 and H3 again and again. In order to write these equations, it's a hectic work. So you no need to write this. I have written here, but no need to write. Simply you just mention step 4 and mention eliminating the feedback path. That is more than sufficient. And draw the diagram. That's it. That is more than sufficient. No need to write like me. I have written here eliminating the feedback path of blocks G3 plus G4 into G5 and H3. It is more specific, but no need to write. Simply mention eliminating the feedback path of the blocks, or simply mention eliminating the feedback path and draw the block diagram and just write down the equation. So what is it? G3 plus G4 into G5 whole divided by 1 plus G3 plus G4 into G5 into H3. That is it. Okay. So now by looking at this, now the circuit has become very, very simple, isn't it? Circuit has become very, very simple. Now I think you can tell me what I can do. What is my next step? Step number 5. Can anyone mention in the chat box? What is my step number 5? What is step number 5? Can anyone mention? Yeah, combining the cascade blocks is our step number 5. So what are the cascade blocks? These two are the cascade blocks. These two are the cascade blocks. So I'm going for step number 5. I hope you have written this. I hope you have written. I don't know how many of you have completed. If you are copying it down, I'm going to step number 5 now. Step number 5, combining the cascade blocks. Simply you have to multiply what? Gain values. For combining the cascade blocks, what you have to do is you have to multiply the gain values. You have to multiply the gain values. Completed? Okay, very good. So you have to multiply the gain values. If you multiply the gain values, what do you get? G1 into G2 into G5. See, usually we write in a sequence 1, 2, 3, 4 order. So that's what I have followed here. So the sequence is always after 1 you must write 2 and after that you must write 5. So that's why I have written in sequence. G1 into G2 into G5 into G3 plus G4 whole divided by 1 plus G1 into G2 H1 into 1 plus G3 plus G4 G5 H3. I hope you also got the same thing. So what is next? Can anyone mention step number 6? What is step number 6? What is step number 6? After combining cascade blocks, step number 5. What is step number 6? Eliminating the feedback path. What feedback path? Positive or negative? Can anyone mention? What type of feedback is it? Yeah, eliminating the feedback path is correct. What is it? Positive feedback or negative feedback? So to be more specific, what you can do is eliminating the so and so feedback path. Positive feedback path or negative feedback path. You can be more specific in your step number 6. Was it, what is it? Positive feedback. Yeah. So what is the formula for positive feedback? What is the formula? What is it? Formula is G divided by, for positive feedback, 1 plus 1, not plus, sorry, 1 minus G divided by 1 minus G into H. So what is our G here? What is our G? This is our G. This is our G. I have talented. My cursor is talented, not myself. Cursor is talented. So feedback path, positive feedback path formula. If you want to eliminate the positive feedback, this is our G. Okay, this is G, this whole term, and this is our H. This is our H. So eliminating the feedback path, what is it? G, this whole term, okay, divided by 1 minus, again this whole term. I will take the laser. Okay, what is G? This whole term divided by 1 minus this whole term into H. This is our H, this is our G, positive feedback. So Y of S by R of S is equal to, you have to simplify this equation, whatever multiplication or common terms and whichever terms you can take common and eliminate, you just eliminate it. Okay, you can just eliminate it and you just rewrite the, I'm erasing all inks. I will eliminate only this. So I hope you have written this. Did you complete this? Whoever is copying it down. So I hope you have completed. Let us go to the next step. So what is next step? Step number 6. It is eliminating the feedback loop. So R of S is input, Y of S is output. So I have already simplified it. And this is what the expression that I have got. So what is the overall transfer function of the system? Y of S by R of S is this. You can copy it down. If you complete, mention. So do you want me to continue for half an hour extra? Or shall I conclude? You can mention in the chat box. If you want me to conclude, I will conclude the numerical problems of this topic. Or if you want me to continue if you want me to discuss one more numerical problem, it may take at least half an hour to solve that numerical problem. So if you want me to conclude, I will conclude it. Conclude the class completed. So you mention in the chat box whether you want me to take class for 15 or 20 minutes more, or shall I conclude? Your wish. Or if anyone have any doubt, you can mention in the chat box so that I will explain it. Okay then. So no response. No one is responding for this question which I have asked. Okay then. So if possible, we will solve few more problems. If I am able to take another session, then in that session I will discuss few more problems on this. Okay. So if anyone have any doubts, you can mention in the chat box and I will clarify your doubts. Okay. Thank you for joining this session.